should be fine.
So it's only the easy stuff?
Did I say that?
Yeah.
Well, okay,
Listen,
if I think L.
Did
the test get moved back today because we lost today?
Yep. Caleb got mad at me a while back and he was like, oh, this isn't anything that we've ever talked about or we haven't talked about it recently. You guys, whole point of those Friday online that you're not supposed to wait till Friday for, those weekly assignments are to keep the things that we've done fresh because this is stuff that's on the AP test. All right, last thing. This is the last deal. We're going to talk about something called linear approximation.
Oh, we won't even be here now. We're back into 3.
Yeah, now go back to 3. This is the last section.
So what do you think the likelihood of us?
I don't even want to go there. I don't know.
What's your name?
Dude, if it would be
I think it's
zero
zero because we got
90.
Agree. Okay. So, linear approximation is basically a tangent line that we use.
Between, this isn't a joke, but between 6 o'clock and 7, it's negative 11 kilosecond. That's as low as it gets.
Yeah, I would say it's not as cold as it was.
They got to. They literally did on Friday. Yeah, they do it all the time.
Think about the bus people waiting for buses, dude. They literally freeze their toes off.
Anyway. What are the things, let me remind you, if you're going to write the equation of a tangent line, what are the 3 things that you need to have? Slope,
Y1 and X.
X, and Y, right? So you need a point and a slope, but it's slope X and Y. So literally the only difference, let me back up and review tangent lines with you. So remember that we talked about this, like if you have a line, this is my f of x original here. If I make a tangent line, like right here, we'll say, what happens if I zoom in on what's called the point of tangency? They overlap, which means that that curve of the parabola looks like it's what? Straight line. Do you remember what that's called? This is a reach.
It's linear.
Local linearity. No. Local linearity, meaning that if you zoom in far enough, it looks linear. It's true for almost every function, as long as there is no cusp. Okay, because if you zoom in on a cusp,
It's just a point. But it's
if you zoom in on a cusp, it's pointy. But in an oscillating function, if you can create a tangent line, so we'll say this, if you can create a tangent line, then you can zoom in on it, and it's locally linear.
Cusps don't have a tangent line, right?
Yeah, they do.
They can't.
She was just saying that.
I just said that. I did just say that. Everywhere except a cusp, right? Because a cusp is going to be pointy. You zoom in, it's still going to be pointy. Okay? So we know that. What a linear approximation line, it's the same thing. It is a tangent line. It just will be called a linear approximation line. So those 2 things are synonymous. So we'll give a little geometry. This is equal to tangent line here. So what a linear approximation line does is it says, hey, you've written this. We know that very close to where their tangent, that's called the point of tangency, in case you missed out the first time. Really close to the point of tangency, they're very close together. And so we use the linear approximation line to estimate things on there. Now, every year they're like, well, I'd have to do that if I know f of x. I think that there are probably a lot of real life applications where you would know how something changes, right? You know its rate of change and you know something about it, so it's original, but you don't have a function for it. So you wouldn't be able to estimate, but you could make a tangent line and do some approximations. Okay, so I have these written out for you, so you don't have to write them. This is another paper for people to lose. This is what it is.
I still have all the papers, even from last year. I still have all the pre-calc papers in my locker too.
I don't know the last time I've lost something from my class.
You told me to keep all the pre-calc stuff because it was going to be super helpful, and then I haven't used it.
That's not my fault.
The only
Should
thing
have.
I would say useful is the unit circle.
Okay.
Get that paper that says do not throw away and it's yellow, but we've never used it.
Yeah.
What one? What yellow one?
The one that says.
Oh, the circle?
Strategies to survive or thrive. Do not lose this paper.
Yeah, and some rules and stuff.
And some rules and stuff.
You know, I lost that paper, and you know what happened?
I would guess that if you read that paper, that you would be like, oh, she says these things to me. Don't do it now, Mason. Okay, so this says, question one. Here is an example of you know a point, you know the slope, but you don't know anything else. So it says, let f be a twice differentiable function. The fact that it is twice differentiable seems like it's a throwaway thing, but it tells you that the first derivative is continuous, because if something is differentiable, it is continuous. If it's twice differentiable, there's no cos, because its derivative is also continuous, the derivative of the derivative. So you know this is a smooth thing, you can write a tangent line for it. Gives you a point, says the derivative of f is given by that function. So use the line tangent to the graph. So before we do anything else, we're going to write the equation of the tangent line. Okay, so whoop, this means tangent line. So please do that. Don't do anything else yet.
How could something be only singularly differentiable?
If it has cusp.
The original wouldn't have a cusp. The derivative would have a cusp, right?
Absolute value is not differentiable.
Like the original would have to look smooth, but then the derivative would have to be a cusp.
You can have a hole.
We don't
You have
have
jump.
y, x, or slope.
How would you get the derivative that have a polar
Yeah,
jump
F
though
says
without the original?
F of 0 equals 4.
What's that?
X and Y.
Remember that you can have piecewise
X is
functions, all kinds of things, right?
No,
So
X
it's
is
not
zero.
just like a single function. It could be a piecewise function that might make things different. You get what I'm saying?
Yeah, maybe.
Basically,
I guess
0.
0.
Okay, what's your x value?
Yeah, that's not
0. This is x, this is y. So you got x and y. All you gotta do is find the slope, and that's about the easiest thing to do here.
Y over x.
No.
Plug it into the.
You have f prime. So literally, yeah, just plug it in. So you end up with the sign of 1, okay, which is a decimal. Okay, what's the sign of 1? By the way, you want to be in radian mode.
How'd I do that?
Go to the
yeah,
mode,
I found
the mode button.
Yeah, maybe if you check it out.
I'm already.
I just switched to it.
In pre-calc, we potentially could be in degree or radian, so they will get switched. Yep.
How do you switch it?
Go to the mode button, right, which is next to second. Yep.
It wasn't at menu 2.5.
I don't know.
Miss Douglas, if I remember bringing my own calculator sometimes, can I charge it in the dock?
Yep. Okay, so sine of 1 is 0.841 because remember you're going to use 3 decimals. So what's the tangent line? Y equals what?
4 plus 0.841 times x minus 0.
Which you can put the x minus 0 or not, but you don't need it in this case, right? Because x minus 0 is x. Okay, now there's your tangent line, no problem. And then it says use that to approximate f of 0.25. So when it says approximate, use the tangent line to approximate this. This is your x value, and it gets plugged in here. That's it.
Okay. And we don't have to do any stupid like
You don't have to-
notation.
No.
That's what I hate.
What do you get?
4.210.
0, because 3 decimals, correct. There you go. Like that's it. That's a linear approximation line. Okay, try number 2. That's what your homework is like.
Oh, sweet. Miss Douglas, my professor said email them if you need help. They'll respond in a day. It's been a day. They don't respond. I'm starting to lose it a little bit.
Yeah.
send them a nasty email.
You should send them a nasty hate
One of them
email.
put his personal phone in there, but I didn't.
Can you please do my problem?
Yes.
Thank you.
I have to work the NHS retail thing. Might I leave like 2 minutes early so I can grab lunch?
Definitely. Now, I'm gonna throw one more thing at you. You may not use your calculator on this one.
Well, too late.
Ah!
Just kidding.
Timesing 1.5, timesing by 1.8, how are we not?
Dude, do 18 times
No,
1.5.
no.
Move the
Okay, let's talk. What's the slope?
Oh, it's 2.
What's the slope?
3x squared over y.
3x squared over y, correct. Right? This is your slope. It says the slope is that. But what's the slope you're going to use?
Negative 1/2. Whoa.
Negative 1.
3 over 2.
4/8.
3 over 2. You guys, so 3 times 2 squared over negative 8. That is 4 times 3. That's 12 over 8. That is 1.5. People?
4/8.
Wait, there's no negative. Why is it not
1/8.
negative 1.5?
It is negative.
Oh, that's what I was saying. I was saying, why was it not?
It is. Okay. Now, I'm going to put that as negative 1.5 because I like decimals.
That's how it works.
So listen, tangent line, y equals negative 8 plus negative 1.5 x minus 2. Now, seems like it's nasty of me to tell you to not use your calculator, but you guys, this thing right here is why we never distribute these. Okay? If we plug in a 1.8 here, okay, you can do that math. What is that? It's 0.2. You can do that math. So I'm going to remind you, whoops, minus 1.5 times 0.2. Remind you, tell you, whatever, how to multiply things with decimals in your head. Okay, so here's what you do. That is essentially 15 times 2. So if you're dealing with decimals, ignore the decimals, right? This multiplication, 15 times 2, which is what? 30. How many decimal places did we ignore?
1.
2. 1 here and 1 here. 1 in each one. So that's 0.3. 2 decimal places.
Or you could keep them in fractions and then you just get 3 tenths.
Keep them in fractions. That would be terrible.
It's really not.
Or you could just do it in your calculator and it does it for you.
No, because then you have to still add it to the negative 8.
Oh. Yeah.
So that would be negative 7.7. Okay, same thing. I would like you to do number 3, no calculator. What?
Asking them a question.
I think the calculator matters.
I learned that
Sixth
like
grade.
we first learned
Never
about
looked at it.
Well, now that you are much more mathematically mature,
Oh, okay.
Hey, just close your eyes, forget the decimal, and then put it back where you started.
I know that. I'm saying I learned it the first time. So closing, a lot of you guys seem like you never heard that before. I was like, wait, what? Just confused.
They're just not
Who's
those like
myself?
this.
Okay.
Like me and you.
Yeah,
The other day I did some long division.
They teach
I don't
you
know
different
why
in Florida.
I did it. Oh, I know what it was. It was that question. It was the optimizing question on the because I didn't want to do the derivative things. So it's a shortcut, but there was no calculator, so I used long division.
well, that's
No, it wasn't that bad.
She taught us long division last year, was it? You made it
slow. Why are you
really long division.
So long division was actually.
You don't have 2 points on the original
Yeah,
function.
yeah. And then we learned about how to equate.
Okay, people, what do you need to write the equation of tangent line? X, Y, slope. What's X?
2.
Right here.
Oh shoot. I
What's
forgot
Y?
the slope.
1, that's Y. What's the slope? Because this is f prime of 2, the slope is 4. There's literally 0 work here.
I can't do it. I like this problem.
Which what's the homework?
Did I say anything about homework?
Yeah.
No, you're written.
I said it's just the homework, and you said it's like the homework. is what you said.
Yeah.
Yeah.
We don't have time.
Tweez.
Okay. This is what I am gonna say. Test will be on Friday, unless we have a massive amount of snow days next week. I'm not moving the test.
You push
Okay.
it back another day just for.
Friday. Test is Friday. Okay. All right. Get your stuff away.
Dude, you know what that means? I'm gonna get